Hi everyone, so this is chapter 9 revision quiz set 3. So there's 29 responses and we are going to go through question 7. I did it in another video, so just question 8 and question 10. So let's move to question 8. Question 8 says that you have the bob of a simple pendulum is being displaced a distance of positive amplitude from the equilibrium position and then release. The subsequent motion is simple harmonic with angular frequency omega. So it's SHM, but just that it starts from the positive maximum displacement. It starts from the amplitude. So now the question asks, how will the velocity changes with time? This is not displacement, it's asking for how the velocity will change with time from the moment the pendulum is being released. Okay, so let's do a bit of drawing. So initially, what we will see is, you see, okay, let's call this our ceiling, and of course, ceiling connected to a pendulum. Then your pendulum is now being displaced. And how much is being displaced? It's being displaced by a distance of positive a right now. Okay, then it's being released. So when it's being released, you travel towards the equilibrium position, move to the negative a, come back to the equilibrium position, and move back and forth like this. Okay, so if you happen to want to draw the displacement time graph for this particular oscillation, this is just displacement time graph. It's x of meter against time second. So it says here it starts from the amplitude. So at time equals to 0, you start at the amplitude, which is a. Then the next thing you see is this bob, when it's being released, you move towards the equilibrium position, then move away from the equilibrium position. So with that, you can sort of imagine the graph to look something like this. Okay, this is a graph drawing. I hope you get the idea. This is the displacement time graph. So if you draw this and immediately you go find the answer, then the answer would be B. But that's incorrect actually. That's incorrect. Why? Because they are not asking for x against t. They're asking for v against t. So there are a few ways you can do this. First thing is you try to get the equation for this graph over here. So it's a cosine graph. You can see it starts from 1, go to negative 1, come back to 1. Okay, if it starts like this, then it's a cosine graph. Then you can just say this is x is equals to a cos omega t. Then if you do velocity, then velocity will just be differentiating this x over here, and you get negative a sine omega t. Okay, differentiating cos, you get negative sine. So you can see that the graph will be a negative sine graph. So which one is a negative sine graph? This is a positive sine graph. This is a cosine graph. This is a negative sine graph. So this is what we are finding now actually. So your answer will be this one. The one at D is actually a negative cos graph, but this is not what we need. We need a negative sine graph. So that's how you determine the shape of the velocity against time graph. So that's for question 8. Let's move on to the next question. Okay, question 10 says a mass on a spring oscillates with a certain amplitude and a certain frequency. If the mass is being replaced with one 4 times heavier, what happens to the frequency? So now it has a certain amplitude and certain frequency, and it has a mass. So the original one will have mass, amplitude, and frequency. So now this time they change the mass. The new mass will be equals to 4 times of the old mass. Then you don't know much about amplitude. They are asking for the frequency. If they are asking for frequency, then means by you have to find f prime. Okay, so they are expressing this new frequency in terms of the old frequency. So it's like the new frequency is the double of the old frequency. The new frequency is half of the old frequency. So if you are comparing the new frequency with the old frequency, what you need to do is you compare between f prime against f. Okay, so if you are not sure how to start, this is where you can do. You can start from omega square equals to k over m. Then you can do 2 pi f straight away, and 2 pi f square equals to k over m. So this will be f square. Then you get 2 pi square km. Then if you move it to the other side, then f square will be 1 over 2 pi square k over m. So now if you square root the whole thing, you see that this square root and the square will cancel out. Then you are left with k over m inside, and outside you have 1 over 2 pi. Okay, so this is the general equation for frequency. So now let's compare it with the new situation. The new situation, f prime, will be equals to 1 over 2 pi. Then you will have square root of k against mass prime. Okay, the k doesn't change because you don't change the spring. There's no mention that the spring is changed. So you continue. The new mass is 4 times of the old mass. Then now we can do a bit of factorizing. 1 over 4 come out. Then you're left with the original km inside. So 1 over 4, if you square root, it's half. Then you're left with the original term inside the bracket. So this thing here is the same as this thing here. So you can see that the new frequency is actually half of the old frequency. So if it's half of the old frequency, then you know that the answer is frequency is half. Okay, so that's how you solve question 10. That's all for chapter 9 revision quiz set 3. Thank you very much.